Hello to all of you. In today's video, we are going to discuss a topic of paramount importance in physics in measurement, that is error and uncertainties. Starting from error. What is a error? Error defined as the difference between a measured and actual value. Whenever any experimenter is taking a reading, there is always a chance of error. It's no matter how good you are not going to take a reading by using any instrument or by using any method that is 100% perfect. There is always a chance of mistake, and that mistake is error. For example, I have a rod and the length of that rod, let's say, is 1.2 cm, 1.2 centimeter. Student A measures that rod, the length of the rod as 1.0 centimeter. Student B measures the length of the rod as 0.9 centimeter. So you can see that there is a difference in the actual reading and the reading that has been taken by student A and B. And there can be various reasons for that. Not talking about the reasons why these errors are coming, that will be discussed later in the video. So, right now, we are going to understand, or we are understanding what is error is. So, it is the difference that we are seeing in both the readings of student A and B and the actual value. Now, what is uncertainty? If I say that error and uncertainty are two faces of the same coin, so this will create a much more definition of both of them. They are pretty much linked. So, what is uncertainty when I say uncertainty? We will discuss uncertainty in detail in the next video, but right now we are only discussing the relation of error and uncertainty and what really is uncertainty is. So, uncertainty is basically magnitude of the calculated error in measurement. As I told you that no measurement can take place without a error. If we want to calculate that error, how much error is coming in our measurement, if we are calculating the magnitude of that error, that calculation, that calculated magnitude is basically uncertainty. And the detail is coming in the next video where we are going to focus only on the uncertainty. So now, let's focus on the error at the moment. Error basically can takes place in two ways, or we can say that error can be of two basic types. One is systematic and the other one is random. So let's discuss both of them one by one. Systematic error. Systematic error can take place in two ways. One is due to instrument, and there are two ways in which error can come in instrument. One is the zero error, and the other one is the wrong calibration. What does it mean when I say zero error? You have done ATPs in your O levels or IGCSE physics. So you have seen this instrument known as a micrometer. And vernier caliper is now not included in the course outline, but you must have know something about the vernier caliper. So what is zero error? I'm strictly talking about the zero error, and I'm giving you the examples of vernier caliper, and I'm giving you the examples of micrometer. So what happens? You are seeing the jaws here, you are seeing the spindles here. When we completely close that jaws and when we completely close that spindle, it has two scales. So their readings are not exactly zero. Okay? Their readings of instrument are not exactly zero. So that error is known as zero error. And if these kind of errors present in your instrument, you can't control it, you have to deal with that error. How to deal with it? It's a different game ball. So this type of error can come, a zero error due to the instrument, and that is systematic error. The second one that we are talking about is wrong calibration of the instrument. What does it mean by wrong calibration? Let's see this reading here. Nothing is placed on this electronic balance, but still it is showing, let's say, 6.88 kilogram. For your better vision, 6.88 kilogram. And nothing is placed here. See, nothing is placed here. Nothing. So nothing is placed here, but it is showing some reading. Now, this is an ammeter. It is not connected to any wire, any conductor, any circuit, but still, this one is the zero of this ammeter. It is showing some deflection in it. It is showing some reading in it without connecting to any circuit, any conductor that has some current in it. So you see that these both the instruments, the weigh scale here and the ammeter here, they are wrongly calibrated. They are showing reading when there is no reading present there. So these type of error can also come, and these type of error can come because of the wrong calibration. So what is wrong calibration? Showing reading initially, it means the instrument can be analog, the instrument can be digital, but what is happening here, nothing is measured by that instrument, but still it is showing some reading. So in these two ways the systematic error can come. There are different ways of overcoming systematic error. We cannot take the average of values to reduce the systematic error. When we say zero error, there are specific methods, and many of you have studied these kinds of things in the IGCSE and O levels lab while you are doing an experiment with the micrometer. So it is not it is not necessary, or we are not talking about that how to overcome it at the moment. We are discussing what is systematic error, how it can come in your measurement. So that is what real agenda of this video, to understand the error, the systematic error and the random error. So now this is systematic error, and we can overcome it by using different methods. Now let's move on to the random error. Random error is come because of experimenter, us, or because of change of condition. It can come because of two things. Let's say you have a lack of knowledge. Lack of knowledge means that you are doing an experiment, but you are using wrong method. You are taking reading in a wrong way. Let's say, for example, you are reading the scale, and by reading it, you are introducing the parallax error in reading meter scale or in reading the volume by using a measuring cylinder. So that random error can come because of the experimenter or because of the change of condition. And it contains that if you don't know what method to use, if you're using wrong method, if you don't know how to use an instrument, or if you don't know how to take the reading. So these are the randoms error. Let's say I am doing an experiment initially at temperature 20 degrees Celsius, and that experiment demands my temperature to remain 20 degrees Celsius. But somehow, due to some conditional change in the environment, the temperature fluctuates from 20 degrees Celsius to 25 degrees Celsius, and then afterwards it becomes 20.3 degrees Celsius. So now this temperature change is not in your control. This conditional change is not in your control. This error will always come in your measurement if the condition has been changed. Yes, but you can know the instrument well. You can know how to take the reading in a much more precise way, in a much more accurate way. So, in this way, we can reduce the random error. And if these kind of errors are coming in the measurements, we can take the average, we can take the mean to reduce the error. So, that is what we learn about the random error. So, in this video, my focus is to just discuss the definitions of error, uncertainty, then the two basic types of error, how they come, and how we are supposed to look at them. So, that is all for this video. In the next video, we are going to discuss uncertainty in detail. And before that, we are going to discuss accuracy and precision as well. So, that is all. See you.